First of all, I would like to thank you guys for coming to this session, and I'd also like to thank USEF for inviting me to this session. It was about 3 years ago. I used to be like you guys. I came here for a standardized test, to prepare for standardized test, for my application essay, for searching colleges, and then now I'm here, and I'm glad to be here. And I would also like to take this opportunity to thank USEF for making me able to give this speech after 3 years. First of all, I would like to introduce myself. My name is Sumit. As Selena ma'am has already told, I'm from New York University. I'm a rising junior. I'm double majoring in physics and mathematics, and I'm minoring in astronomy. And I just came back from New York completing my research. And I used to be a research assistant with one of the Harvard astrophysicists who was my professor. And then I work under Center for Cosmology and Particle Physics. So in today's session, I would first like to give you a little introduction about NYU's Global Network University, which is a little bit different from traditional and conventional United States education. And then I will talk about my research and what I've learned from my travel that I have traveled to around a dozen countries within NYU, and then what I've learned from that experience. My talk is not that long, so if you have any questions related to the present topic of discussion, you can just ask me any short questions, or you can keep those questions and you can ask me at the end of the session. So NYU was established in 1831 in New York, but since then, till 2013, NYU has expanded throughout the globe. So NYU is not just in New York, but right now NYU has 3 portal campuses. You can see in the map marked blue, there are 3 portal campuses, one in New York, the other in Abu Dhabi, and the other in Shanghai. Apart from that, NYU has 11 global academic centers. Accra, which is in Ghana, Berlin in Germany, Buenos Aires in Argentina, Florence in Italy, London in United Kingdom, Madrid in Spain, Paris in France, Prague in Czech Republic, Sydney in Australia, Tel Aviv in Israel, and Washington DC again in the United States. So this was the vision of NYU's NYU Global Network's president John Sexton, to expand NYU and not just make NYU within New York, but make NYU in and out of the city. Now, how does that affect you? So you have the chance to get a global education by traveling to any of these global sites. The good thing about it, it's just one application process gives you access to the entire global network. What do I mean by that? So you guys have all, I guess, heard about common application, application essay, standardized test, and all those processes that you need to do in order to apply to any of the United States colleges. Same thing. You do the exact same thing. You have the common application, you have the supplement, you fill out the exact same thing, and then you just tick mark that you also want to be selected, you also want to be considered for the campus in Abu Dhabi and for the campus in Shanghai, and just one application gives you access to all these global network sites. Why global network sites? What John Sexton believed was, after your 4 years of education, the students who graduate from NYU should be a global citizen who are aware not only of their community, not only of the place that's within their national boundary, but then go beyond boundaries and collaborate with students from throughout the world, and then work for humanity, not just being constrained within a national boundary. So with this concept, NYU Global Network was established. And every global network has something unique to offer. I chose to enter NYU's global network through NYU Abu Dhabi. Why did I choose NYU Abu Dhabi? After now having spent around 1 year or so in NYU Abu Dhabi, I have hundreds of regions. But before I joined NYU Abu Dhabi, I just had 4 or 5 regions. Few of them. Student to faculty ratio. Student to faculty ratio can even be 1. You will have 1 professor teaching just you for the advanced classes. And they are not graduate students. They are professors who come from elite universities from Stanford, from Harvard, from MIT, from all those colleges. For example, I had a physics class with me and my roommate, and then we were taught by a Harvard astrophysicist whom I ended up working under in the NASA project, which I will describe in shortly. And 20, it's about the 20 students will just be in like some foundation classes, like foundation of science, foundation of mathematics, like calculus classes, but you won't exceed a class which is more than 20. So, no, I'm not just talking about NYU Abu Dhabi, but please do consider these factors when you are selecting your college. Do you want to go to a university where there are about 30 to 40,000 students, where you will have the university experience? That's not bad. I mean, it's your choice. If you want to go to that those universities like MIT or even NYU in New York has about 40,000 students, that's a traditional experience. If you really want to go to there, then NYU Abu Dhabi is probably not the university you want to come to. The next is international diversity. NYU, the place I went to for the first time in NYU Abu Dhabi, my class size was 150, and the students came from about 60 different nations who could speak about 50 different languages. This was what really intrigued me to come to NYU Abu Dhabi. Because I wanted that experience so that each discussion I have with my friends becomes an intercultural experience for me in the global education. You will get rid of all the stereotypes you have with Chinese people, or you have with Arabs, or you have with African Americans. You will get rid of all those stereotypes. And I would like to quote the Vice Chancellor of NYU. What he said was, he overheard two guys, one was from Kenya and the other was from India. They were talking with each other and they were saying, we have been through all this experience and we have studied in same class. Just imagine, after we graduate, and if you hold some good position in your governmental office and I hold some good position in my governmental office, then just imagine how the bilateral relationship between Kenya and India would be. Exactly, this is the concept why we need an international diversity in the campus. Third point, probably the most important point for me as well and most of the students out here. NYU's Abu Dhabi campus has a very, very, very generous funding. How? If needed, NYU Abu Dhabi has a capability to give a full ride to all the admitted students, also including stipends for your personal expenses. That without any loan or work. I'm not giving a scam here. This was possible because of the generous help from the Crown Prince of Abu Dhabi, because he believes in this kind of global education, and then what he believes is no student can be restricted just because of financial restrictions. If you have that capability, and if you want a global education, and if you want to make a difference in humanity, then money doesn't matter at all. You'll be funded everything, like literally everything. You need to pay nothing, including your own personal expenses throughout 4 years. Next is something called Candidate Weekend. So what NYU Abu Dhabi does is, NYU first selects the students from the application you just submitted through common application, like any normal colleges. Then they select about 2,000 students out of around 40,000, depending upon how many students apply. Then they select those 2,000 students, and then they fly you to Abu Dhabi. Every expense is paid for a weekend. So you have the chance to go to Abu Dhabi for free without being admitted, but if you are just a potential candidate, and then you can experience the campus, how the campus is, who the professors are, and you can take some sample classes. Do I really want to attend this university? Then you will have the chance to also talk to some seniors like us, and you can have all those experience, and then you decide if you want to go to that college or not. But that does not mean you are still admitted. They select only about 150 students out of those 2,000 students that they fly to Abu Dhabi, just to make sure that you are a perfect fit to the community. And if you think you want to go to that college, you're welcome. Otherwise, you can go ahead with something else. So it's just a free ride to NYU Abu Dhabi, and then check out the college if you are a potential candidate. But mind it, it's 2,000 among about 30,000 or 40,000, and the number is increasing year by year. Finally, all the travel opportunities. Within 2 years, I took some classes in NYU Buenos Aires, I took some classes in NYU New York, and I took some classes in NYU Abu Dhabi. I went to NYU Berlin and some other dozen countries just to take some classes and then experience how the global community is, how the world is operating, what's happening in Europe, what's happening in North America, and what's happening in South America. And everything is funded. Not only that, if there is something, if there is some place that you really want to study, for example, if you are taking a Spanish class, then nothing can be better than taking that Spanish class in NYU Madrid or NYU Buenos Aires. If you want to take a French class, then nothing can be better for you than to go to NYU Paris and take that class. There was one of my friends who came to Nepal and took an independent study in some community in Kavre, then he went back and then he wrote a research paper about it. So wherever you want to go to, you're welcome to do that. And NYU will take care of all your funding. And in this opportunity, now I would like to change the topic a little bit, and I will describe how my research experience has been so far and what all those neutron stars and what all those stuffs are. So I took this opportunity to travel elsewhere, and then I went to NYU in New York, and then I got an opportunity to work under my professor who got funded from NASA to work on some stuff, which I will explain later. Then I started my research in my freshman year, because there were only 4 students who were under that professor, and he said, why not work together? Then what I did was I started using data from something called Swift Space Telescope. So NASA has already launched like lots of space telescopes. What they do is they just orbit around Earth, and what they do, they just take pictures. They are just camera. Not the camera that we use to take Facebook profile picture, but they are pretty advanced cameras. They just look at sky and they just take pictures, either in optical that we normally see or in X-ray band, but they are just cameras. For example, this is the image from Hubble Space Telescope. So it just looks and points at the sky, just takes an image, very simple. And then here, this is the image from something called Large Magellanic Cloud, where you can see billions of stars out here, and the blue region is just a glowing hydrogen. So it just looks at the sky, a region, and then takes image. What I did, I tried to find group of galaxies which are clustered together. For example, this is something called Abell 1689. That's the most massive galaxy clusters known to us yet. What it does, it just has like trillions of stars and dark matter in it, and it just works as a gigantic lens. What it does, it just bends the light that comes from behind and then just magnifies the light. This is one of the galaxy clusters, and I took this image from Hubble, but I was working on a different satellite called Swift. I didn't include Swift images in my presentation because the X-ray images are like not that interesting. So Hubble's, it works in optical, so these are like a bit more interesting astrophysical images. And you can see all these like bright spots out there. And among like one of these bright spots is what you guys may probably recognize is our own Milky Way galaxy. And solar system is somewhere around in one of these arms. So this is what really inspires me to do the research in the field of astrophysics. See the scale. We are here in USEF. Think about Earth, think about solar system, think about galaxies, think about galaxy clusters, think about universe. Just being a human being on Earth, we have the ability to research what's going on in nature. It's really summarized by what Stephen Hawking once said. We are just an advanced breed of monkeys on a minor planet with a very average star, but we can understand the universe. That makes us something very special. This is what always keeps me going, and this is what really interests me to work in the field of astrophysics. This is what I did in my freshman year, and then we have summarized the list of galaxy clusters, and then we're still working on it. But recently, I'm in a vacation for 1 month, but I just came back from New York after completing a different project, and I studied something called a pulsar wind nebula from 2 different satellites again. And this is one satellite which is called XMM Newton, again same type of satellite, but this is from European Space Agency and not NASA. And the other is Suzak, which is from a Japanese aeronautical company. And then what I did was I studied something called pulsar-wind nebula, and this is what a pulsar-wind nebula looks like. This is an image of Crab Nebula, which has been known to humans for a long time. This is just a supernova remnant. What a supernova remnant is, when a star runs out of fuel, what happens is it just bursts open, and the core of the star, if it's around 1 to 3 solar masses, then it gravitationally collapses, and then what remains is called a neutron star. And all these things like around, like all these fuzzy things, these are just wind of charged particles. And I had the opportunity to study one of these pulsar-wind nebula, which we believe is a bit weird than other normal stars. Why is it weird is a bit more to discuss. I'll not discuss about it yet, but we are hoping that we'll publish the paper and then explain why is it weird than other normal stars. This was all about my research that I did in my first year in New York and that I just completed in the second year. Now this is my last part of my talk, and what I wanted to say is, what did I learn from traveling to all these countries, and what did I learn through all these research? These are not like some academic lessons, but I really learned something extraordinary while traveling to more than a dozen countries and then researching in this field that I did not have opportunity to study before I went abroad. And in this, I would just want to say like a few things that I learned from like pretty extraordinary people that I met within my journey. So first is, what I learned is always have that capability, that ability to accept, to face failure, but never give up on your passion. If you are really passionate about something, don't give up. For example, you guys may be applying to your dream college, you guys may be applying to lots of colleges right now. It's kind of sure that you'll have some rejections. But don't give up on your passion. If you really want to do something, if you really want to do engineering, if you really want to do something, just go ahead with it. I learned this from this wonderful gentleman. I don't know if you recognize from him from this uniform, but if anybody here is a sitcom fan of the Big Bang Theory, you might have seen him in 4 or 5 episodes as a guest star. Right now you can identify him. He's a veteran NASA astronaut who has been up there in space twice, once in 2002 in Colombia and once in 2009 in Atlantis. He was the first person who used Twitter up in space. And I got the opportunity to learn like valuable lessons from him. And his space commander applied 18 times to NASA to become an astronaut. 18 years he waited. He applied, I think, around the age of 35 or 30, I don't exactly remember his age, but he applied again and again and again. Sometimes they would say, I don't think your eye is good so that to go up there in space, you need a laser surgery. Sometimes they would say something different, sometimes they would say something different. He applied about more than 30 times in 18 years, but he was really passionate about being an astronaut. Even he himself, he applied for 5 continuous years again and again and again in the NASA to be an astronaut. So he was really passionate about it. And finally, he went up there into space twice. And he had an interesting story that he shared with me regarding teamwork. What he said was, so when he was working with his team, so they work like hundreds of hours in Earth just to not make any mistakes when they go up there in the space. And then they go up there in the space, and he's an MIT graduate and he's a mechanical engineer. He goes up there, and then he starts. His job was to just take out the battery from one unit in Hubble Space Telescope and just replace the other battery. But then he just couldn't unscrew one knot bolt of that whole thing. And now he's just sitting there, he's frustrated. People have spent billions of dollars to send him out there, but he just cannot unscrew one knot bolt and cannot just replace thing in his spacewalk. Then he just looks up, and then his space commander is looking at him from up there in the deck, and then he just gives him a thumbs up, saying, nothing has gone wrong. Just calm down and just work, you know. And then he does everything regarding all those emergency responses he had learned, and then he completes the work. And then he comes back, and then he talks to us, and what he says is, do you know what really made difference at that moment? Was my leader giving me a thumbs up rather than showing me a middle finger. That's the thing
team, like, it's just like a chain. If there's some weak link in your chain, then you gotta first make sure that the weak link in the chain is upgraded along with you. This is what I've learned in my research as well. If you are in a bad condition, if the situation has already gone worse, so if the situation is already bad, then you are the only one who can make it worse. Nobody else can do it. So really, it's all about teamwork, and then having everyone upgrading the whole team in a whole research, that big project, not just trying to do everything on your own. Finally, this is what I was talking about our NYU's president John II. This is what he says: playing another octave of piano. What does he mean by that? He means if you are playing a piano, don't just dig into trying to play what you have learned yet. Try to explore. Try to explore a different octave of piano. This is the whole concept of liberal arts education. Try to explore. Most of the students, most of my juniors, when they ask me what do I study when I go abroad? What do I major in? This is not your time to think about what you're going to major in. You have 4 long years to think about it. When you go abroad, try to explore. Try to take that class that you always wanted to take. Up to here, most of the students, either science or management or humanities or something else. If you haven't taken some class in music, but you are really interested in music, go ahead and take that class. Don't fear because your grades will be low. You will never have this opportunity. You will never have this wonderful 4 years again in your life. I took classes in religion. I never had thought that all the messages in the Bible, the Quran, the Bhagavad Gita, everything is the same. We just believe in a different messenger. I took classes in celebrity culture and fame, and I learned about Kim Kardashian, Paris Hilton, and things, and people still study about that. I took classes in social entrepreneurship. I took classes in all those things that I never imagined that I would take just being a physics major. So you have that opportunity. What NYU believes in is to make a student's mind a T-shaped mind. What that means is you have the breadth, the width to cover different area, and then you have a depth in a specific field. Whether you want to do engineering, whether you want to do physics, whether you want to do economics, whatever. If you haven't tried some food, try that. If you haven't taken some class, take that. If you haven't been to some place, then go to that place. Just remember 2 things. As long as it's legally and morally acceptable, just go ahead and do that. That's what you are there for your 4 years. Now I would like to leave you guys with one thought experiment that always keeps me going. Whenever I'm trying to do something new, this thought experiment always keeps me going. And this was proposed by Salman Khan. Not the Salman Khan, the Bollywood actor, but the Salman Khan, the MIT and the Harvard Business School graduate who started something called Khan Academy, and he has thousands of videos, and what he believes in is free education for everyone and everywhere. I guess most of you have at least seen 1 or 2 videos about your curriculum in Khan Academy. Imagine yourself in 70 years. Then there you're sitting in a couch thinking about all the successes you have had in your life. You are all graduated from your graduate school, you have done everything. And then all of a sudden, you start thinking about all those things you thought you might have done differently. All those regrets in your life. For example, you wish that you would have given a tight hug to your parents and say them how much you appreciated them before it was too late. You wish that you could have asked out a girl in your class out for a date before it was too late. You wish that you could have taken the class that you were really passionate about, but you didn't because you were too scared that your grades would be low if you took that class, and then your career would have been somewhere different. But you didn't do that. All of a sudden, a genie comes up, and then he says, I've been eavesdropping on your conversation, and I think you're a good guy. I think you need to be given a second chance. He snaps his finger, and you are right here. In August 9, 2013 in USEF at around 2:30, and then you say, it's really happened. You got a second chance in your life. Now you have this opportunity to explore, to give a tight hug to your parents and say how much you appreciate them. You can laugh more, you can dance more, you can
do all those things you have already done for the first time, but you can optimize your time now. You can do it differently. And I'm here, glad standing in front of you, that I have been able to give you a session. And then now it remains to see what you're going to do with your second life. Thank you. So I just had a kind of short conversation, short discussion about NYU and then my research and what I have learned and what I've learned from the interesting people I have met during my research and during my travel to about a dozen countries. So now if you have any questions regarding anything about NYU or anything, just let me know.
My question is a little bit broad, but have you ever thought of like bringing astronomy in Nepal? Like, is there a chance that it happens?
Till now, my plan has not been that far. So I'm just a rising junior. I just spent 2 years in New York. So I'm still planning to do my graduate studies first, and then like get a PhD, and then I'm definitely gonna come back and do something here, but I haven't thought like till then, because I still want to explore, and I'm not sure if I really want to be an astronaut, because I still want to explore some different fields, and then we'll see what happens at the end. Any other questions regarding anything? Mm-hmm.
Yeah, why are you studying the most bright neutron star?
Sorry?
Neutron star, why are you studying that neutron star, most bright neutron star in our galaxy?
So there are lots of things. So there are lots of things in the universe that physicists haven't really understood. What we know of as matter, it's just like 1%. There are about 75% of dark energy and about 24% of dark matter. We don't know what's really in the universe. We just know about 1%. So what we believe is, if we study those things, then maybe we can use them later on. For example, when Einstein discovered general relativity, nobody knew what to do with it. When he discovered special relativity, nobody knew what to do with it. So he said, if you travel to the speed of near to the speed of light, then time dilates or something happens. But like people were like, I don't travel to the speed of light, so what can I do with it? You know. But after about 10 years, everything, you have a cell phone or everything that works on GPS technology, everything needs to be general relativity and all those things need to be taken care of. If you launch a rocket from here, and then if you don't take special relativity and general relativity, you wanted to land in the moon, you probably land somewhere in Mars. You know. So right now, what physicists we do is we just study about things and try to figure out how nature works. We don't really know right now how we can use for human benefit, but it's definitely sure that sometimes in life, like later on, after 10, 15 years, we'll be able to use that. So it's the same concept about studying a neutron star. We don't really know what's there in a neutron star. We don't know much about what happens after supernova. So it's all about like learning what happens and how nature works, so that we hope that we'll be able to use it later on in our life, like a GPS technology or maybe a future energy source. You don't know.
Since NYU is prestigious institution, I want to ask, how did you get into it? Just we are in the phase of getting into good college. What is your that unique and different strategy that made you through the NYU?
So everything, while applying to NYU, all the process is the same. Like you submit a common application, you submit all your transcripts and application essay, everything. What I think is NYU really does not care much about your NYU doesn't really care much about your standardized tests, but it really focuses on how you are different as compared to your community, as compared to other applicants. I think my application essay really made that effect, I guess, but maybe not. I don't know really. And how I got into NYU Abu Dhabi and then have been able to do all this stuff is, I guess I was really well when they took my interview, and then when I sat there for my sample class, and then when I interacted with others. And it's not, what I think is, it's not really that you need to be a genius in your field to get into some college. The thing is, whether you are a perfect fit to that community or not. It's not that if you have like very high grades or a very high SAT score, they'll really accept you. It's not about that. Do you really fit into that community? I explained some of the stuff what NYU is looking for. So if you really fit into that community, then I guess that's for you. Rather than just they saying like my SAT scores are high, my academics are high. Like I don't think that really matters. It matters like everything, the whole thing matters, and they check whether you are a perfect fit to a community.
I've tried to find the answer to this question a lot of times. You showed us the picture of all the galaxy clusters, and then you showed us the picture of the Milky Way. But we have never gone out of the Milky Way, so how do they take the picture of the Milky Way itself? I mean, who takes the picture of the Milky Way?
For example, the picture I showed you, it's an artist rendition. It's not the exact image you see of the Milky Way itself. But what we do these days, it's like the concept astronomer previously was someone like Galileo sitting here on the Earth and sitting with a long telescope and looking at the night sky for the rings of Saturn. Like that really doesn't work these days because we need to take the image of deep space. And to take the deep space, as I said, there are satellites that are revolving up there. So what you take is you take the image of what you actually see rather than the whole Milky Way. That's a good question, like you cannot see the whole thing, but that's what I showed you, and whatever you see, it's just artist rendition. Like that's not the image you exactly get from the telescope. Like, and the other thing is, solar system revolves around the Milky Way, so at this point you might have this image, at this point you might have the image of this thing, and at this point you have the image of the other whole thing. So even at that point you can, in that way you can get the image of the whole Milky Way. But most of the images you see, those pretty pictures, you don't really get all those pretty pictures. Even I like took all those images from Hubble Space Gallery because what I worked on, like we don't really see those kind of pretty pictures. Those are just artists trying to be more fancy to make you understand what a Milky Way looks like.
Excuse me. Doesn't light take billions of years to reach from the stars to the Earth? So I heard that the images that we take or that these telescopes take are those of the galaxies and stars that existed billions of years ago.
Yeah.
So they might not be present
Exactly.
right now or not. So how does that time change astrophysics? The study of astrophysics.
Like it really doesn't. So what you are
what you are seeing in the telescope or what the images that telescopes show you are not of the stars that are present.
Exactly. So you are not getting the image, like you are not getting the image of the stars that are right now there, but you get the image of the stars like after, for example, after 10 days or after 20 days or after 1 year or after 2 years, but you're getting the image of the whole life cycle of the star, right? Or whenever you started taking the image. That really doesn't matter. We're trying to figure out how nature works rather than like we're not okay. Up to now, we're never gonna go to a star. That's for sure. So right now we are not trying to go to the star and like whether it exists there or not doesn't really matter. We are trying to study how nature works, how the laws of physics work outside, how supernova works and how all those stars work. So it really doesn't matter to me whether it's there or not. But it was there and I'm taking the image of something that existed like a long time back. And you can calculate from the redshift and all those stuff when it existed and what those properties are and all those stuff. Like I don't really need the star to be exactly there because I'm not trying to go there. So.
Actually, I heard that, and I'm not sure how correct it is, but the stars that we see probably are existing during the Jurassic era, and that is pretty long stretch, right?
It really depends how far the star is. For example,
no, not stars in general. I mean, all the galaxies that we see, the other galaxies.
Exactly the same thing. How far the galaxies and how far the star is. Galaxies composed of like trillions of stars. So it depends how far the galaxies are. I think it was 1 or 2 years back that we detected the signal from the edge of our universe. So which was like long back. So it depends how far the distance is. If the distance is like, I don't know, 4 or 5 light years ago, like the Alpha Centauri, which is the closest star except Sun. So we detect the image very quickly. For example, you guys might have heard about Voyager, which just is about to cross the solar system. That satellite was launched in 1977, and it has been running on and on and on and on. And Scientists don't know whether it's going to cross the solar system, but let's hope it does. So yeah, it depends on the distance what you're talking about. Some galaxies might be way, way far, some might be.
So how do astronomers make all these predictions
Predictions of what?
of how the universe works? I mean, the things that they used to make those predictions are pretty dated, 150 million years ago. That's a pretty big stretch. So things might have changed, by now, from 150 million.
But what I'm trying to explain is, for example, if you got something that's 150 million years ago, tomorrow you'll get something million years. So tomorrow you'll get an image what happened like 1 day after in that star, and the day after you get the thing what happened the 2 days after that. So you really can make out the age, what do you call it, like the age chart of what happened in the star. Like rather than saying it existed, it might have changed. But I'm not gonna know what happened in that star right now. Never. Maybe I'll know it 150 million years after. I'm not gonna know it.
Actually, doesn't the patterns of how the
It might. It might.
So what is saying right now was how it works.
Yep, exactly.
So it might be different.
Might be different.
So is it correct to say that it is right there?
No.
It works this way.
No, at all. It worked like that 150 billion years ago. But it's the laws of nature. Laws of nature don't change every day. There is a law.
Yeah.
If that law is true and if that holds the observation, then it does not change as you are thinking about it. If it's a law.
I didn't mean the law, not mean the laws in general. Of course, the laws is.
Okay, I think I'll give chance to other students, so we can discuss about this later on. I'll just give chance to other students. Thanks for the question.
You said that you are going to come back to Nepal, right, after you complete your studies. So what are your plans after you return to?
I mean, it's the same answer I gave to somebody who asked me. I really don't know what I'm gonna do. I'm not sure if I'm gonna be an astronaut. I'm not sure if I'm gonna be an astronomer. I'm just exploring. This is just my 2 years. I might explore and be a civil engineer by the end of 4 years. I don't really know. I'm just exploring, and I'm exploring the opportunities that I get from this global education. I might just start my undergraduate school in engineering, aeronautical engineering, a completely different field. So I haven't really thought about that, as I said, and I don't really want to think about that because I really want to take advantage of the liberal arts curriculum and explore, and then at the end I'll make my mind, but not now.
Can you give us what your SAT score was?
I didn't give SAT, it was like ACT or something. But as I said, SAT scores are really not, standardized tests are really not the make or break factor in colleges like this.
After you were selected, you straight went to Abu Dhabi or the New York University to work.
First-
How did it span out?
First I went to NYU's campus in Abu Dhabi. Then I spent next semester in NYU Buenos Aires. Then I went to NYU New York to do my research, back to Abu Dhabi, back to Nepal, back to New York, back to Abu Dhabi. Then I'll go to New York after I'm done with this vacation.
Do we need to choose at that time of application process whether we are going to attend this of the colleges or?
So you are not gonna attend one college for the full 4 years.
And for the first year.
Yeah, it depends which portal campuses you are admitted to. Every campus has something unique to offer. It does not mean that NYU in New York and NYU in Shanghai gives you that very generous funding. They have their own funding system, and every portal campus has their own funding system. So you have to go just to nyu.edu and then just look at it.
Like an example, if I get full funding in the union, if I transfer myself to Abu Dhabi.
Okay, first of all, it's not transferring. This is the concept you need to understand. It's not transferring. You're just in the global network, and you're just going to different. You are getting a degree of New York University. You don't get a degree of some portal campuses.
Okay, if you are going to the next place, then do we get the same as we are going at this first year?
Depends on which portal campus you were admitted to. I was admitted to NYU Abu Dhabi, and yes, you get the same funding. That means you don't need to pay anything wherever you go. But NYU in Shanghai, which just opened in 2013, and NYU in New York, which was opened in 1831, it has like its own policies.
Means we can choose which course we are going to take.
Exactly.
Like were you interested in astronomy beforehand? Like, did you do research regarding it, or were you exposed to the field after you entered NYU?
So when I went to NYU, I first took classes. As I told you guys, I took classes in religion to see if I'm really interested to take classes in religion. I took classes in engineering. I took classes in physics, and I took classes in astronomy. Then I did a summer research in my freshman year in astronomy, and I really think like that's my field right now. So I'm trying to major in physics and math. So I really didn't know what I was going to do before going to NYU. But then I made up my mind that I will complete my bachelor's in physics and mathematics and astronomy.
You worked on NASA, right?
I analyze these data from those telescopes.
I thought you worked.
For example, to go in NASA's its own office, let's say, which are like in lots of places. For example, there is some JPL laboratory in Caltech. To go in all those institutions as an intern, you need to have either a PR, permanent residence, or you need to be a American citizen. So just to go and work under those offices. But these days you don't really need those, because you can work remotely. You just need a computer and you just need to sit in front and then work remotely and connect with data from those satellites. But as an employee, you can work.
Can you please describe briefly what you wrote in your application essay?
I mean, for application essay, if I tell you what I wrote, and if you try to judge the...
I was trying to know how you explore, how you are trying to explore in that university.
So
how you enroll there.
For example, I just wrote something about myself, what I think about myself, what I plan to do, and all those stuff, and which was very, very personal to me. Something that would be very personal to you, and what makes you stand out among all those 40,000 applications is really your own application essay, rather than somebody else's. So write something that really shows who you are, rather than trying to judge what the admission committee would want you to write about yourself.
But were you most fascinated by
Me? I thought I would either study physics or engineering, but I had no idea what I would be studying.
Was NYU a dream college, or you just got into it and so you made it a dream college?
As I explained something about candidate weekend, I was flown to Abu Dhabi to see the campus, and then I was like, visit.
You might have been accepted to many colleges, right?
I got accepted to 3-4 colleges, but that was, I thought, according to what I thought was that was my best fit, so I just went to that college.
Where did you finish your master's?
Oh, I graduated from Brilliant Middle School 3 years ago.
Were you offered full scholarship at the first college?
Sorry?
Were you offered full scholarship?
So in NYU, Abu Dhabi, if you get admitted, whatever you ask for, you get it. So depending on your financial ability, like you have to send all your financial documents, but I mean, if you are not able to pay something, for example, 100%, you can just say, I cannot pay anything. They'll give you whatever you want. Any other questions?
Is Carnegie Mellon Qatar campus similar to New York University?
Carnegie Mellon right now is in Qatar, which is, from my experience, and I have some friends there, it's not a global network university, but it's a branch campus in Qatar, in Doha. It's what I explained everything. It's NYU in Abu Dhabi is not a branch campus. NYU in Shanghai is not a branch campus. All those 11 global sites I mentioned are not branch campuses. They are just a part of NYU's global network. I mean, I don't have much idea about Carnegie Mellon in Qatar, but I just said what I heard. But I would suggest you go and check with someone who studies there or in their website.
Okay, well, thank you very much to Mr. Sumit Dahal.